In this tutorial, I would like to tell you what we are going to achieve. So if you go to Etherscan and see here, there's various token types they are displaying. We are going to create ERC20 token. If you click on ERC20 token, for example, click on BNB, it is going to show you that BNB is the token, this is the max supply and many other things. What we are going to do is we will create a token of our own and it will be able to show something like this. As you can see here, we are going to create a token called TOK and it will be our first token and it will have a supply of 100, something like this. So we are pretty much simulating a cryptocurrency coding or a token creation coding. Please follow each step because I am walk you through from setting up the test environment to wallet understanding, coding, testing, everything end to end. Creating a token, as I just explained and showed you, is very easy, but we need to do certain steps. And the steps are shown here. That is, first we need to set up a wallet. Then we need to understand the coding environment. Then we have to code a smart contract. Then we need to deploy that smart contract and actually test our smart contract. And then ultimately we will see our token in Etherscan. Okay. So these are the steps. These steps will be explained in detail but in a very easy way and in a quick way. Please follow step by step without missing anything, and by the end of this you will be a winner and you will understand how to create a token. Let us now learn about metamask and also set up the same. Metamask is a wallet which you can use for Ethereum transactions. It can also help you in deploying your smart contracts and also test the same. I am using Microsoft Edge browser. Therefore, what we have to do first is Google it like MetaMask extension Edge. So you will end up here. I'll click on that. Okay. So click on Get here. Add extension. Okay. Basically, it will add to your browser extension. So let's wait for it. So the extension has been added. If you see this is the MetaMask extension. So now this is a welcome page. Let's get started. See, there are two things here, okay? One is if you are totally new to MetaMask, you have to start this way, create a wallet. But let's say you already have an account, you can start this way, okay? Now let's say I have already account, but right now I want to show you how to create. So let's do this. Create a wallet, okay? See, first you need to give a password. So give a very good password. Okay, just click on next. See, what will happen is once you have a password, it will give you a secret phrase, which is very important. This phrase you need to keep it with yourself because in case you miss the password or something, you can use it to unlock. Okay, so click here. So it gives you something. Okay, keep it somewhere safe where nobody can see that. Okay, now what you do is click on next. So it will ask you to select that phrase in the same order. Okay, so let me show you one by one. So my face was this: horror, focus, dilemma, 10, pattern, guide, potato, office, trophy, local, caution, height. See, this was my phrase. So you have to click in the same order. Once you do that, you confirm. So say yeah. So it is passed. That means all done. Okay. See, it will give you it will come to you. Okay. So by default, if you see, there's one account created for you. Correct. So this is your account. Okay. You can use this account to actually transfer ethers, get ethers, etc. See, you can see here, right? Right now you have 0 ethers, correct? So you can buy ether or send ether. That's what it is, correct? And it will show you, see, this is the asset you have. So you have 0 ethers, okay? And not just ether, several other Ethereum based tokens you can have, that will come up here, okay? Now if you see here, right now if you see Ethereum mainnet is choose. This is the main Ethereum network. If you click on here, you can see here, there are several networks here displayed, correct? Ethereum mainnet is a real thing. Then there are some test networks. These test networks will help you to deploy your own smart contract. In the sense, you can create your own tokens and everything and deploy it, okay? So that you can test it before you go into mainnet, okay? Now if you see how many accounts you have only account, only one account is 0. See, what you can do is you can create couple of more accounts, okay? Just give any name you want. So it created a one more account. So if you see here, you have two accounts. So you can create as many as you want. Once accounts are created, which you can see here, there are 3 accounts, you can start doing transaction. You can buy real ethers, sell ethers, etc., etc. Okay, all those can be done on Ethereum mainnet, but that is not our focus. We are doing token development or smart contract development. That is, we are going to create our own token, our own crypto, just like Ether. So therefore, what we'll do, we'll buy some, test ethers, because without ethers we can't deploy and do any transaction. So therefore, we have to get some test ethers. So switch to something, okay, Ropeston or Coven or Inkiwi or whatever works for you. Let's say Coven, okay. And then what you do is you click on buy. It will ask you, okay, test faucet, right? So you click on get ether, follow the procedure, and you get some ethers to each of these accounts. So ultimately, after this transaction, you should see some ether here and some ether here. Do that procedure for each of the accounts, okay? Then we will start with the contract development process. If we have problems getting test ethers, which normally have, you can go to this website ethdrop.dev. This is for Coven network. Just give your Ethereum address, click on get ETH, and you will get an Ether. For example, I will show you. I have given this my contract address. I've clicked on get Ether. It says, click on wherever motorcycle is there. See, you say get ETH. So it is sending a ETH. So hold on. Send, okay. So you can come here, you can check in your metamask, okay, you can whatever account. See, I have 0.001 ether on Coven test node, correct? Or account 2, if you see, I have 0.02 ether. Then I have 0.0, right? But if you see on mainnet, you don't have anything, correct? On Ropeston, you don't have anything, correct? That means it is valid only on this network. So, right, I got, right? So you can do like this. So we have ethers ready, we have accounts ready, we have metamask ready, right? So we have wallet ready. So this, using this wallet, we can actually go to the next steps of deploying some smart contract to these test networks, okay? So we'll go step by step. To create our own cryptos or tokens or smart contracts, we need two things. One is a development environment where we can write our programs. Second is a programming language knowledge. So we are going to use Solidity as the programming language and Remix as the software development environment. Remix is an online development environment. Okay. So therefore, let us Google Remix Ethereum. You will get this website. If you know this website, you can directly type it. Click on that. So this is an online development environment. Okay. Wherein you can write your smart contract code, compile it, deploy it. So we will see and also test it. See, if you see here, there are many folders here. The first one is the File Explorer. File Explorer is where the place where you will put your programming files. Okay. Now, second thing is, this is where you compile. You give compiling options and compile. This is where you deploy to certain test network that I have already showed in metamask. Okay, and then you can test it also. So you code, you compile, deploy and test. Okay, this is the three things you need to remember. Okay, see, if you see, go to File Explorer, you have an option of loading a local file into this. I have already loaded a file here. If you see, there is a file here. I have already kept it ready so that I don't have to show it, right? See, this code is not like I have invented this code. This is what is called as a ERC20 format. Okay, so it's a standard way of creating tokens. It is pretty much, you can say, copy paste. I have copy paste this code, but I will explain each and every line of it so that you can do your own modifications. Where can you get this code? You can go to Ethereum, okay, ethereum.org, and then you can just Google it or check it. You will go to a place where you will see the code here. Okay, you can just copy it and just use it. Okay, the only modification I have done is, if you see here, there is some interface, and then there is something and all. I have removed all this and kept it very simple. Okay, so that I don't have to worry you with inner intents and everything. Everything whatever is required is there in this contract. Okay, which I will be explaining. Now, before we start understanding this coding, okay, we need to understand what is ERC20. Okay, that is the first part. What is ERC20? See, ERC20 actually, it's nothing but, if you see here, again, see, your everything, the source of your knowledge should be from ethereum.org. What is ERC20? It's a standard. Okay, what is the standard? To create tokens. Tokens like what? Like Ethereum, etc. Okay, now what happens is, this is ERC20 by default provides certain functions and everything which you need to code. That's it. You need to have those functions like I just showed, right? This function, there are many functions like this, right? Like if you see, total supply, balance, allowance, transfer, etc., etc. You need to code your thing. You put your logic in it, but these functions has to be supported. That's what is the ERC token standard. That's what we have done in this. Okay, I have just taken the framework, but here I am going to put my code, meaning I have to create my token, right? And I need to put my own logic. That's what I will change it. But the framework is already fixed. Who has fixed it? That is why it's called a standard. What is the standard? It's called ERC20. What is the standard for? To creating tokens in Ethereum. Now time to understand each line of this code. The first line you would see is this SPDX license identifier, and MIT is one such identifier which I have chosen. What does this mean? A license identifier is going to tell you how your software can be used by others. So MIT means, if you go to that SPDX and MIT, you will see that the user can have full rights to use, copy, modify, merge, publish, distribute, etc., etc. without telling me anything, right? Basically enjoy. Similarly, there are many licenses for SPDX list. You can see what you need to provide and choose accordingly. Okay. The first. Second is the compiler version. What is the compiler version in which I am going to compile this code? If you see, I have said 0.8.0 something. And if you see in the left side compiler, there are many compilers here. I have chosen the latest compiler version. Correct? That's what is the latest. Now the third part is contract. The keyword called contract, name of the contract, and then everything that required to be in the contract is put in this, right? These three are the main things that you need to understand, correct? So I'll repeat. One is the license identifier, which you can choose Just put it MIT for now because it's all anyway not our code as such. Choose the compiler version. Then all your contract related code, you put it in contract. Just give a name for something. Okay. Name of this contract class. Put everything in this. Meaning it's already put. Okay. That's the format. So we have to now understand what each line in the contract means. Okay. So in your contract, first you will define certain constants. Okay. Name will have the name of your contract, your smart contract. You can give anything you want. I have just said my first token because this is a smart contract for token. Then you give the symbol that your crypto has to use. I am saying TOK. It is like ETH. Okay. It is same like that. Okay. But I am saying it is TOK. What is these decimals? We have to default it to 18 in Ethereum. The reason is in Ethereum the base unit is called V, okay, and it is expressed in the form of 10 to the power of 18. That is, one Ethereum will have 10 to the power of 18 V's. So it is recommended to keep these decimals as 18. Okay, I hope you got it. Name of your contract, the symbol you want to use for your crypto, which is I am using as TOK. You can say ABC or XYZ or whatever. Then 18 defaults. Okay, this is the first constant declaration you start with. Before we move on, I just want to remind you again that in Ethereum or in any cryptos, you are uniquely identified by a hexadecimal number like this, correct? So that is your unique identification. This is your account number. So this is what you're going to use for sending and receiving ethers or any other coins. And your address will have balance. For example, account 2 has 2 ethers here, correct? And if you see account 1 has 0.01 ethers, correct? So that means an address will have a balance, right? So therefore, Solidity has to provide support to store all this, right? So two things that Solidity provides is a data type called address, another data type called mapping, mapping. So what is it? Okay, so if you see here, this is the data type. What is the data type? It's called mapping data type. What it is mapping? Address to a value, some integer, correct? That means if you declare a variable of this type, if you see here, balances is of this type. So what will balances will have? Each value in balances will be a combination of address and some integer value. And we know, as I just explained you, basically this balances, each element of balances will have an address and its balance. Address is balance. So if there are 5 addresses, address 1 balance, address 2 its balance, like that. Okay. And what is address? We have already explained. This is the address. So there is an address data type also defined, obviously. So two key data types is, one is mapping, correct, and another is address, correct. So mapping will map an address to, in this case we are mapping an address to a balance, and address itself is a data type which will hold the address like this. Okay. So now I hope you already understood this. That means we have already declared a variable called balances, and each value of balance will be having a mapping of address to its balance. What is the address? We have already explained, correct? I come to events later. Now there is one more mapping. What is it? That means now what it is mapping? If you see, it's like a nested mapping, right? Right? An address is mapped to something else. What is it mapped? Left hand side is address. Right hand side is something else. That means it is mapped to again nested address and balance. That means what we have to understand is there is some owner, correct? Right? Some address is there. Okay? That address is telling, let's say owner address, let's say father. Father is saying son can have so much balance. That's what is this. Okay? Father is saying son can have so much balance, which you can use it, right? Or a mother is telling my daughter can have so much balance, which she can use. That's what is called allowed, correct? So I repeat it. So there are two things, a balances and allowed. Balances is going to map address to its balance. Very simple, straightforward. Okay, let's say I have a account 1, I have some 10 ethers. Second is allowed. What does it mean? If the word itself is clearly decimal, right? I am using a nested mapping. That means what I am saying is I am allowing somebody to use my balance, right? So what I am trying to say, this owner is telling this address can use this balance, this tokens. That's what it means. Okay. Then there is one more variable called total supply. What is this? See, total supply is very simple. As you may know, for example, Bitcoin. Bitcoin, the maximum limit is 21 billion or something, correct? 21 million, sorry. Similarly, in our token also, we will also create a limit. So total supply means this is the maximum supply I am going to have in my token forever. I am going to use this variable. Okay. Now, how does this total supply get initiated? Okay, somebody has to say, right? So when I am deploying this contract, what will happen is a function called constructor of this contract will be called. Right? If you see, this constructor is accepting a parameter. I will run and show later. Okay. I am using this value and I am assigning it to total supply here. Correct? What I am doing? I am taking total that I am passing when deploying and assigning it to total supply. So when this constructor is called, what will happen is I will have a limit of my token. Let's say 10 million tokens. That's all I'm going to have in my token. Like Bitcoin has 21 million. Same way I will have, let's say, 10 million. So it at any point of stage, the total supply cannot be more than 10 million. That's what it means. Correct? Now what is this? Okay. Balances of message sender is equal to total supply. Right? See, balances is this. Correct? And what is this balances? It's a mapping between address and balance. So how I'll access this is anything is I have to give this one, you will get this one. So what I'm doing, message.sender, that means whoever called this contract deployment, right? That's what msg.sender will have the address of whoever called this, whoever deployed this contract. So I am storing balances of whoever called this deployment as the total supply. Okay. I think maybe a little confusing. I'll repeat. Okay. First thing, we are defining three variables here: balances, allowed, total supply. Okay. What is that? Balances, each element of balance is going to have a mapping of address to its balance. Allowed is basically a nested mapping. Basically, it's like father telling that son can use so much of mine. That's what it means. It's a nested mapping. The thing is, another is just an integer, unsigned integer, 250. It's a total supply. It's just the name of the variable. So, what is total supply? As I told, it's like 21 million bitcoins. That's the total supply. Of my token, it will be something whatever I pass. So, when this contract is deployed, a function called constructor will be called. You can pass input when you deploy this contract, which I'm going to show later. Whatever input I pass, let's say I pass 10 million. That will be assigned to this total supply. That's what you're doing here. So once this statement executed, the total supply of my token is set. Now, what is the next thing we are doing here? If you see here, whoever deploys this contract, okay, his address will be there, right? That will be there in msg.sender. Whoever sender means this is the person who is deploying, right? So what I am saying is balances of sender is going to be this total supply. See, let's say I am deploying this contract. I am officially the owner, right, of this contract, right? So how much I should have balance to start with? Total supply, right? I am going to have everything, right? Because I am the one who is going to distribute to everybody, right? So I am saying I am going to have entire total supply. That means if it's 10 million, right, to start with, whoever is deployed this contract will have 10 million accounts. 10 million ethers or tokens, TOK in our case. How it is achieved? By using this, right? Address to balance mapping. How do you access the thing? You say balances and you give the first one, that is msg.sender, which is the address of the deployer, and you are assigning a value, which is this part. It has two parts, I told, right? Balances has two parts, address and balance. So I am assigning address, the balance I am assigning. So once the contract is deployed, now what will happen is there will be a variable called total supply, which will have whatever total supply I am starting with. Second is whoever called this contract, whoever deployed this contract, his balance will be total supply. Let's say 10 million. Okay. I hope you understood. Let's say at any point of time, you want to just get the value of how much is the total supply. This is the function. So you define a function, like you use keyword called function, and the function name is called public because anybody can access. It's called view because you can only read, you can't write it because you can't keep changing the total supply, right? So it will return what? Total supply. So later, once this contract is deployed, if you want to get the total supply of this token, whatever, right? How much is the total supply in this token? Let's say you want to get it. If you call this function, it will return that. So if we have started with 10 million token, okay, it will return as 10 million. Now at any point of time, again, if you want to know how much balance is there in an account or an address, you call this function. How it is coded is a very simple function, balance of. Obviously, you need to give which address you need to get balance, right? So I have to take the input as the address. Okay, it's a public function. It is just going to read it. Returns integer. What it is going to return, as I told, the balances is stored in this balances, correct? Address to balance mapping. If you see, whoever you are asking to give the balance for, I'm going to use this. So balances of that address, if this token one, if you say balances of this address, I will get the balance in that because of this mapping. Address to balance mapping is there, right? So when I call balance, when I say balances and I give the address, I will get the balance in that for that address. That's what I'm returning. I hope you understood. Okay. Just quickly I'll summarize so that you know before going to the next step. Okay. The first key thing is what? We need to understand two important things: mapping and address data type. Address is the account address. Mapping is the key value. That means for this particular data, for particular this one, there will be this value. So what I'm saying in balances is I'm storing the address to balance mapping. Allowed is basically like nested. Okay, as I already explained, father has given permission for son to use so many tokens. It's like that. Total supply is the total supply I'm planning to have in this token. Like Bitcoin has 21 million, I am saying something. So how this total supply will be initiated? Obviously it has to be initiated when the contract is deployed. So when the contract is deployed, a function called constructor is called. In that I have to fill this variable. How I'm going to do? I'm going to pass the value in the constructor, which I'm going to fill it up. And whoever is starting this contract, whoever is deploying this contract, I am giving the total supply to him. Okay, have it. So the contract owner, whoever is created this, deploying this contract, will have all the 10 million tokens. How I am doing that? Basically using this balances of msg.sender is it will have the address of whoever is deploying it. So I am saying balances of this owner who is deploying it will be total supply. Okay. Now later we will be transferring from this guy to somebody else and all those things. Transaction I will show you. Now at any point of time, if you want to know the total supply of this token, just call this total supply. And how it is coded? Function total supply. It's a public function. You can only view. It will return this variable total supply. Similarly, at any point of time, if you want to know balance of an address, you call balance of function. That you have to code these functions. Okay, balance of. So obviously balance of some addresses. So you have to take address as the input variable, right? So how it will give the balance? Basically call balances with the address. If you say balances of address, what will you get? You will get this one, balance. That's what you are returning. I hope you understood. So what and all we have done so far? We have defined the name for your contract. We have defined a symbol called TOK and we have set 8 decimals. Then we have understood what is this balances array. We have understood this allowed. We have understood the total supply and we have understood the constructor, which is going to be called once. We have also understood two functions that is already coded, which is going to reply the total supply of your tokens, and also it can give you also the balance of any particular address. So I hope you understood the syntax also. Okay. Before we proceed into the next function, I want to quickly explain the library. Basically, we have defined a library called safemath. There are two functions, subtraction and addition. Subtraction will take two integers, okay? It will give the difference. Addition will take two integers, it will give the sum. And if you see, it's an internal function. That means it cannot be called from outside the contract. It's a pure function, meaning it will not touch the state of your ledger, right? That's what it means, right? And then you have to now understand this using safe math for unit. What it means is these addition and subtraction, right? You can directly operate on this any variable which is defined of this data type. Uint dot if there is something which is like this data type, you can directly say dot add dot sub like that. Okay, that is something we need to see because in a couple of places we use like that. I want you to also, I hope you understood. We are defining a library called safe math, two functions sub and add, which is going to give us a difference in addition. Then we are saying using that library for this data type, which means whenever you declare any variable of this data type, you can directly say dot sub dot add. Okay, for example, if you see here, I have a balances, right? Address to balance. So I on this balance I can directly do sub and add, which I am going to show later. Okay. Let us understand how to transfer tokens from one person to another person. So for that there is a function defined called transfer. Okay. So it will accept the receiver and number of tokens to be transferred. Where is the sender? Why it's not given here? Because the person who is calling this will automatically be a sender. That is message.sender will be automatically the person who is calling this function, right? So you don't have to pass this as input. So therefore, function transfer, receiver input, address, number of tokens, it's a public function. Okay. So let us understand this function. The first thing you need to do is check whether the sender has balances or not. Does he have the required tokens? Check that. That is the first check. Let's say he has the required number of tokens. All you have to do is from the sender, remove the number of tokens, meaning subtract it. Now to the receiver, just add it. Very simple, right? From the sender, you are subtracting the number of tokens that is given. Yeah, so that means you are removing from him and passing to the next person, right? That's what it is. To the receiver, I am adding from the sender, I am subtracting. Simple. Then I am emitting a event called transfer. Okay, with the value of sender, receiver, and number of tokens. So what is this event? How it looks like? It's defined here. Event transfer from to and token. Correct? I hope you got it. It's very simple. The function transfer is to transfer tokens from one to another. The source is basically the person who called this function. Destination is given as input here, address, and the number of tokens also is passed. The first check is whether the sender has required tokens or not. If he has, from the sender's balance, remove the tokens. From the receivers, you add the token. So that means it's a simple math, right? Once it's done, you emit an event called transfer. That means it has been transferred. So somebody can use it. Pretty simple, right? That's it. Now time to understand the delegation part. As you remember, we did a nested mapping here, right? The parent is allowing the son to transfer so many tokens on his behalf. Mother to daughter, so many tokens. So these allowed need to be filled up with such delegation. Therefore, there is a function called approve. Therefore, what will happen is this approve will accept two input parameters. One is to whom you have to delegate, how much, and who is the parent or the delegator, whoever is calling this function approve. So what will happen is when you call this function, the parent is delegating to his child so many tokens. So message.sender is the parent. The input parameter delegate is to whom we are delegating so many tokens. That's it. So when you call function approve, this is going to be filled up. That means the delegation is filled up. And obviously you are emitting an event that such an approval is done. If you want to know how much has been delegated for a particular combination of the parent and the child or the delegator and the delegated, you have to have this function allowance. So you pass the source, that is the parent, the delegated who is the child. If you pass these two addresses, this will going to return the balance, that is how many tokens has been delegated in this combination. That means mother, daughter, combination, how much can be done. That means how much a daughter can do on behalf of the mother. That's what. So it will return so many tokens. It's very simple, right? I hope you got it. Approve is to fill up this nested mapping. That is delegator, delegated, how much. To fill up that, there is a function called approve. To know how much has been delegated, there's you can allowance function which will return that. Now let us understand the transfer from function. See, basically, if you see the transfer function, when it is called, whoever is called from that particular person's address, we are passing to the sender, to the receiver, correct? So here we are not accepting the sender's address at all, because it is assumed that whoever is calling this function, from there we are sending to this person. But this function transfer from comes in relation to this delegation. What we are doing is, let's say somebody calls this function, right? That function is actually transferring on behalf of this owner to somebody else. So delegation is action. That means message.sender is what? Is the delegated person. The delegated person is transferring from delegator to somebody else. That means message.sender is the delegated, is transferring from owner to somebody else. That's what it means. Therefore, first we will check whether the delegation is there or not. From owner to this person, delegation is there or not, and he has the required tokens or not. Once he has, then basically since we have the delegation capacity, so from the owner we are reducing the balance, to the receiver we are adding the balance, and how much is delegation is in balance, we have to subtract, right? Because see, let's say 100 ether has been delegated for you, right? 80 we have already transferred. Let's say we have used that delegation authority, we have transferred, let's say. Now that we have to reduce, right? That's what is this. Very simple. I hope you got it. See, this nested mapping you understand again. Parent, child, so much can be used, you have authority to transfer, let's say, right? Mother, daughter, so much authority to transfer, so many tokens. So how do you fill up this? Using this approve. That means you have to give approval. That is mother, daughter, so many tokens. To get that, what you are doing? Mother, daughter, how many tokens? This will return. Now this function is, let's say now daughter is calling this function, transfer from. She is calling this function to transfer from her mother to somebody else. So first you will check whether she has a required authority and tokens. Yes, if it is there, then she will reduce the balance from her mother's account, increase the balance in the whoever you are sending, and then her own delegation capacity, the tokens will reduce because she is now used up. Pretty simple. That's it. Now let us do a quick summary of the entire code before we compile and deploy and test. First is this SPDX license. If I say MIT, it is free to use in any form you want. Then I am giving the compiler version by using pragma statement. Then I am creating a contract, and all the code of the contract has been created in this. Right? I have also defining a library called SafeMan which has subtraction and addition function. Now in the contract, the first thing you have to understand is we have to define three things, which is the name of the contract, the token that we want to deploy, like TOK, which is similar to Ether. Okay, the decimal points. Then the constructor. Okay, in the constructor we will initialize whatever is required to be initialized in for this contract. Essentially what we are doing is we are initializing the total supply of these tokens by filling up this variable here, and then whoever deployed this contract, in that we are giving the entire tokens to that person. Okay, message.sender will always have the address of the person who is going to call this contract or deploy this contract, etc. Okay, now then there are various functions, right? Total supply will give at any point in time the value in this, which will be always fixed. Balance of will take an address, will give the balance of that address, how many tokens he or she has. Transfer is transferring from whoever called this function to somebody else. Therefore, the checks will be in place whether they have the required tokens or not. If it is there, he will reduce from the sender, add it to the receiver, then emit a event. Approve is to approve delegation. That is, the sender is approving delegated so many tokens on behalf of him. Allowance will give that value. Now transfer from function is basically now the delegated person is calling this function transfer from. To transfer tokens from the delegator is parent to somebody else. Therefore, delegation checks are done, then reducing the balance from the owner, adding up the balances to the receiver, and then reducing its own delegation tokens. I hope you got it. I think let's go on to the compilation stage. Let us now compile our code. Okay. For that, you need to go to this place. But if you see, before going this place itself, it's saying a green button and it says compilation successful. How come? Because I have already enabled auto compile. Okay, for example, if you see here, if I remove this, it shows an error immediately because auto compiler is on. Okay, now let us understand the compiler a bit more. Okay, so if you see compiler version, there are so many versions. I have given 8.9 latest version because I have chosen that way. That means I want anything in 0.8 dot something. That's what it is. Okay, then the language is solidity. Okay, auto compile already chosen. Now, if you want to manually do everything, you can uncheck this auto compile and keep on pressing this compiler whenever you want to compile. Now, compile what? See, you may have some 10-15 contracts in this, IDE. If you want to compile any specific contract, you can choose contract here. Okay. So I am only choosing one contract here. Okay. So it's compiled. So if you want, I can again show in manual also compile. Okay, I hope you got it. So it's all ready, it's all compiled. Now the next part is we need to deploy. To deploy, you need to come to this tab. Okay, and you have to play around with some of the things here. The first one is the environment. See, environment is, if there are couple of options here, we will choose injected web3. Okay, why we choose injected web3? When we choose injected web3, it automatically takes the metamask extension you have and the account you have already chosen also currently. If you see, this account is ending with 6 here, right? If you see, it is already chosen this account. So what it means is, now to deploy this contract, it is going to use this account because this account has some ethers, right? It is going to use this account and it is going to deploy in this network, which means, okay, environment is where you are going to deploy, right? And how we are going to deploy, all this matters, right? So if you choose injected web3, it auto detects metamask. So you have chosen Coven test network and account also is there. So it automatically selects that. So then you can easily deploy, right? So if you change also, it will change. Okay, this is the first important point. So choose as injected web3. It auto selects the network. Okay, Coven test network. Auto select the account also that you have opened as of now. Everything is ready for stuff deployment. Now these are the things which is about the ethers you have. That is already we have enough ethers, so don't have to worry this point. Now the contract to deploy is this contract. Okay. Now let us understand what is this. So you have to click on deploy button. Basically you have to click on deploy button so that this contract will be deployed to Coven network and the owner who is going to deploy is this account, right? Now what is this input parameter? Okay, that's the main thing to understand it. Now as we already discussed, this contract as a constructor, correct? When we deploy any contract, first the constructor will be called, and if that constructor has an input parameter, in this case it has, so it will expect you to give that input parameter or else deployment will not happen. So if you remember, what is this? This is going to be our total supply of the token that we are going to create, which is TOK, correct? So let us give. See, generally as I discussed, this is all playing around with a ether's lowest level unit is called V, so which is 10 to the power of 18. So let's say we create 100 and then give 18 zeros, 1 2. Okay, so we are giving input parameters, right, which will call when we click on deploy, it will call this constructor and this total will be given this value and total supply variable will be filled with that, and the person who is calling this, this is the guy, correct? This is the guy who is calling, right? Balances of who is the message sender, this is the guy. These guys balance will be set to the same thing. You hope you got it. So when you deploy this, what will happen? Okay, it will deploy to Coven network using this contract address, and the input for constructor will be this value. In our constructor, what we have done, we have taken this value, which will fill up our internal variable called total supply. We'll also fill up the balance of the sender, which is this guy, to total supply. Okay. So I hope you got this. I'll repeat this once again because it's very important. To deploy, we need to deploy somewhere. So we choose an environment as injected Web3. The moment we choose as injected Web3, it auto selects the metamask configuration you have currently enabled, which is Coven test network and account 2. So it is taken Coven test network and account 2. Then it will show the function here for constructor because we were yet to deploy, right? So this deploy is when we click that, it will call the constructor of this. Okay, the constructor has the input parameters, therefore it is asking input. So if you have two input parameters, it would have asked two things. Since only one is asked, so once we give this value, it will fill up this total supply variable, and also the balances of sender will be set to the same value. Who is the sender here? In this case, this is the account. I hope you got it. So once this is done, this account will have some tokens, correct? Whatever, see, these tokens will be there in this guy, and also internal variable. Okay, so we need to now run and show you how it happens. So after having set everything, we click on deploy. The moment you click deploy, you see there is a notification window that opened from MetaMask. So it is going to ask, let's say it is saying I'm going to use account 1. Okay, that's account 1 here because we have changed the account. So it's saying I'm going to deploy it and requires so much gas, meaning it needs so much ether to deploy. Fine. So we are fine with that because we already have ether, right, in all of the three accounts. So we are using account 1. We don't have issues, and we are going to deploy in Coven test network. So we need to confirm this. Okay, the moment we confirm, after confirmation, the deployment happens, and you can see here deployed contract. One thing you have to understand is any contract that is deployed will have its own contract address, and this is the address. And you can see in the downside, right, the thing that happened here, right? See, this is what happened. Okay, this we'll see later. To deploy this contract, this is what happened. Okay, so now successfully we have deployed our contract to Coven network, and this is the contract, the person who deployed the contract, and this is the address of the contract itself. Got it? The contract itself will have an account. You have used an account, some other account to deploy. Okay, these two things you should know that they are separate. Okay, now we need to understand and how do we test this. Let us go into testing part. To verify or test this contract, you are using deployed section only, and you see the deployed contract here, which you already deployed, correct? So what will this deployed contract mean? It will essentially represent this entire code that we have written, meaning it will show option for all these functions so that we can call this function. We should be able to see these variable values. That's what is the testing at this level. Okay, so if you click this, you will see this. See, approve, transfer from, these are all functions, right? Balance, allowance of see, and then decimals name symbol is variables here, correct? Constants, and total supply is a function. So let's test it. Okay, so see, total supply. Okay, see, total supply is a function here, right? You don't need any input path, so that is a total supply. So I click on this, see, you got this value, right? Why? Because when we deployed, we gave this value, correct? When we deployed, this is the input we gave to contract. So this is my total supply. On this contract, this is my total supply. So let's say I want to get to know what is the symbol, right? So you click on symbol. It says TOK, correct? This is the constant name. Now if you click on name, it will say my first token, right? And if you click on decimal, it say 18. You understand, right? So this is the contract address that we have deployed. What it has deployed, this code it has deployed, and this code has got a new address. In that we are checking the value. So we called a function total supply. It will call this and it return that, which is this. We just check this constant. It will give exactly what these constants were, right? Right. Now we'll also say balance of, right? So balance of what? You remember when we deployed, we used this account, correct? So as you can know by constructor, it would have filled this guy's balance also as the total supply, right? That's what is this stuff, right? Whoever deployed this, he will have the total supply. So if you see, that was happened here. So he has a total supply, correct? That's the total supply. So that's how it is. It's a very simple thing. So we have tested many things, right? We have checked two functions, that is total supply and balance of. We have also read this name, right? So this is the kind of testing you can do. Then you can yourself try transfer from, okay, everything. Okay. To test any of the functions that we have not checked here, you just go to the contract, look its definition. Let's say transfer function. What does it accept? It accepts the receiver and the number of tokens. So you have to give a receiver address and number of tokens. Let's say you want to test approve, you have to give the delegate address and the number of tokens, right? Approve. So if you want to test transfer from, you give the owner and the receiver, right? And the number of tokens, 3 parameters. So that's how you test. Remember, in a real life application, we won't be sitting in front of Ethereum, this remix Ethereum, and doing all the work. It will be a web application or a mobile application through which it will internally call all these functions using the contract address. So I hope you remember that this is just to show you a unit testing, how we can test our own contracts. I hope you understand this point of the thing. Now, as you know, we have used this account to do the contract deployment, and as per our contract, this should have our tokens, right? That is TOK, right? But if you go and check in metamask, why this account one, that is what we have used here, right? Why it does not have the token? It is just having ether. Why not our token is there? Okay, so if that is the issue, you click on add token. Here you have to give the contract address. So what is the contract address? You can see here, right? This is the deployed contract. No? Select the contract address, come here and give contract address. The moment you give contract address, you see the symbol automatically fills up. Sometime if it doesn't fill up also, you please give it. So then click on next. See, it says token TOK balance 100k. So then you say add tokens. Okay. Now you come here. See, that means now your account, which is used for transaction deployment here, it not only has Ether, it has 100 TOK. What is TOK? Remember, this is our crypto. This is our token. Just exactly like ETH. Now you can do send, you can do whatever activity you can do. I hope now you understood that we have successfully created tokens. We have deployed it. We are seeing it in the wallet too. This is like a good testing that we have done. Now let us verify whether our TOK has come in Etherscan. So what we'll do, we'll click on this in this account, we'll click on this token, our token, and we'll go here and we'll check on Etherscan. We want Etherscan, right? And if you see in Etherscan, our token is there, token, my first token. Okay, TOK is our symbol. Max supplies, we know that we are given 100 TOK, right? That's what we are given initially. This is the balance, right? So exactly, this is exactly like any other. For example, if you take in ether scan, right? Let's say some other token, it's a live token BNB. It's exactly like that, but this is on the main net. If you see this on the main net, correct? But our token is on the test network, Coven test network. So we have achieved that, correct? So far, we have deployed our token in a test network. However, let's say we want to deploy a token in a main network. Okay, don't think it is very difficult. It is exactly the same steps. It's just that you will deploy on a production network. That's it. Now, that is the main net. But for that, you can also do some additional steps. It's not mandatory. You can do that so that the users of your token will have more confidence. For example, if you go to Etherscan and if you click more, there are some services. Okay, token approval, it's in process. There's something called verify contract. If you click on that, you can give a contract and everything, and you continue. They will verify your, contract and code. And if you see here, you can also check other contracts which is verified. So, for example, let's say you see they have even the code you can see. You understood, right? So this will give more confidence to persons who are going to use your token. That these are the additional steps you can do just for more clarity. Okay, or else it's the same exact procedure. Okay. Congratulations and well done. You have completed this tutorial and now you are well versed in creating any Ethereum smart contract or token in itself. I hope you really enjoyed this whole tutorial and I hope you will do much well in blockchain and in smart contracts in general. Please keep in touch. You may like and subscribe to my video so that we can do much more together than individually.